and that is like pitch, yaw, and roll control. So, and as Suyash mentioned, like I was fortunate enough to get an hands-on experience with the RCS thrusters when I was way back in 3 years. And it was like the first hardware of entire Skyroot that was qualified for flight grade integration. So it was a really great experience going on with the entire test campaign, the data analysis and everything. And yep, now it's in the rocket. So yeah, feels great.
Right, Hakil. I saw that you are mentioning pitch, yaw, and roll, and different parts of Vikram 1 handle different pieces of that. I mean, different components handle different pieces of all those things that you mentioned. On the way up, the solid rocket motors steer and pitch and yaw by swiveling their nozzles. And roll, as you mentioned, which is the spin around the rocket's own axis, it's handled separately, as Suya said, by a small dedicated liquid system during the climb. And once in space, the OM does its own fine pointing with the help of its own small thrusters, which help steer the rocket.
Roll control. So we achieve roll control using small cold gas thrusters.
Good morning and welcome. Vikram 1 now stands on the first launch pad at Satish Dhawan Space Center in Sriharikota, ready for its first test flight. This is Mission Agaman. Hi all, I'm Saravanan. I work in the liquid propulsion team here at Skyroot, which is on a mission to open space for all. Behind me is MaxQ, our headquarters and one of the 3 campuses we have here in Hyderabad. Today, we have got something really special for you. Let's head inside. I'm joined by Kirti, who works in avionics and who's been building this vehicle for quite a few years.
Good morning. Every day for the past few years, Vikram 1 has been something that we were still building. Today, it's on the pad. That's a different kind of day.
Well, this is Skyroot's second mission after Vikram S in November 2022. The first rocket successfully launched by a private Indian company from the Indian soil. And now, Vikram 1 is our first attempt to reach orbit.
Before we join the live launch broadcast from Sriharikota, we would like to share the journey that brought us here. The co-founders who imagined it, the team who has built it, the people across India's space ecosystem who believed it was possible.
Let's go back to where it all started.
Hello, I'm Bharat. I'm one of the co-founders of Skyroot Aerospace.
Hi, I'm Pawan. I'm co-founder and CEO of Skyroot Aerospace.
Both Pawan and I joined ISRO in their biggest center, which is their Rocket Development Center, where we got to work hands-on on their largest rocket India has ever built, LVM-3 Mark III.
At ISRO, we not only got hands-on experience working on complex rocket technology, but we also got the front row seat of the entire space industry. And at that time, SpaceX has proved that space is not only for the governments, private enterprise can come, build new technology, solve problems differently, and build a very scalable, large enterprise. And that inspired us to think why can't we build a globally competitive space company right out of India? Because India has a heritage of 6 decades in space technology. We have our own rocket technology, one among 7 countries who have that capability. We have a great geography for launching. We are very close to the equator, and we have wonderful infrastructure, launch pads, a great supplier and vendor ecosystem in the country. So we felt it's a wonderful opportunity to actually have our own pie in the global space market by building a competitive, scalable space company from India. Then we quit our jobs and started Skyroot with one mission: to open space for all. Our rockets use cutting-edge technology manufactured at scale. One of the first biggest technology which we used is building the entire rocket with carbon composites, and carbon fiber is 5 times lighter than steel, making the rocket very efficient. And the other technology is 3D printing. So typically rocket engines have hundreds of components, and with 3D printing you can build it just with one component.
And to build all of this, it needs state-of-the-art facilities to design and manufacture these rockets. Skyroot operates India's largest private rocket factory in Hyderabad, spanning over 250,000 square feet. And here, we have advanced equipment and machinery like automated filament binding machine, autoclaves, clean rooms, environmental test facilities, and precision machining facilities. All of this will enable us to manufacture 1 rocket a month.
At Skyroot, we've been fortunate to have an exceptional set of people, very diverse team. We have people, very youngsters, passing from the top tier colleges in the country to veterans, each of them having 40 years of experience in various fields of building rockets. All our people are driven by the culture of first principle thinking, technical rigor, passion for rocket technology, and fully committed to our mission to open space for all.
Every company has a founding story. And what's interesting about Skyroot is how specific the vision was from the very beginning, and how it has directly led to the rocket stack on the pad today.
And that vision didn't become a rocket overnight. It took years of building the team, the technology, and eventually Vikram 1 itself. Let's see how this all came together.
Firepower. That's the heart of the rocket and also the biggest engineering challenge. Let's start at the beginning. Our first stage motor, Kalam 1200. It's our most powerful solid rocket motor, loaded with 30 tons of propellant and can generate a peak vacuum thrust 10 times that of a single Boeing 737 MAX aircraft engine. Our second stage motor, Kalam 250, is loaded with 6 tons of propellant and is optimized for higher altitude. And finally, our stage 3 motor, Kalam 100, which is smallest among the 3, is designed to operate in near vacuum conditions.
Rocket's first 3 stages were pure fire and fury, but the last stage, that had to be something else entirely.
Thrust gets you to space, but once there,
You need something that you can start, stop, and restart. Pretty much adapt in real time.
to achieve this, we have developed a stage powered by a liquid engine. This stage, which we call the Orbit Adjustment Module, sits at the top of the rocket, and its job is to place the satellite in the exact orbit, not close, but exact. First, our engine, Raman 2, our 3D printed engine, which can be ignited, shut down, and restarted in space. Then there are smaller Raman mini thrusters and cold gas thrusters. They control the pitch and yaw and help steer the stage and fine-tune the path.
Every stage before this was about brute force, but our OAM is about control.
Orbit isn't just conquered with fire alone.
It's achieved with accuracy, with timing, with intelligence. The rocket is not just about power.
There's no pilot, no joystick, but just the intelligence we built into it.
To build this intelligence, we first start with the rocket's trajectory, configuration, and the mission sequence.
Mission design gives us the ideal path to the orbit. So we design our algorithms for the rocket to follow this planned path, while also making smart and efficient corrections in case of any deviation. These GNC algorithms work along with the flight sequence software that decides
When to separate the stage, when to ignite the next, and ultimately guide the vehicle to the intended orbit.
To run and execute these algorithms, we have a flight computer and the electronic modules on board the rocket.
But avionics isn't just about these modules. It's the complex system of sensors, cables, modules, and actuators that run along the vehicle. It's the nervous system of the rocket.
And just like nervous system, each of these systems are complex. For instance, how does a rocket sense in which orientation it is in and where it is headed? So the rocket has a system called the inertial measurement unit, which has an accelerometer, a gyroscope, and a magnetometer.
And How does the rocket communicate with the ground station? Through a telemetry module.
And at the core of this network is the mission computer named Ramanujan. It tells every other module what to do and when to do. It takes input from every sensor, runs GNC and flight sequencing algorithms, and gives commands to the rocket. It is the decision maker on board.
And this decision maker needs to be trained for every possible flight outcome. We connect the sensors, mission computer, and run the flight sequencing algorithm through special simulators at our lab.
And we test for every possibility: loss of GPS, engine underperformance, sudden wind gusts, even sensor errors.
Intelligence on paper isn't enough. A perfect plan in the calm air means nothing in the storm.
Before even we could think of the launch day came the unforgiving chapter to prove that every part can survive the test.
Qualification wasn't just one test, it was a campaign.
These tests took place over several months, first at component level, then at system level. Take for instance the Kalam 1200 rocket stage.
The composite structures were put through multiple stress tests to check whether they can withstand the violence of flight. The nozzle actuation was tested separately to validate the vehicle steering accuracy.
The safety system of the motor was validated, and so was the igniter. And only when we were satisfied with the data, we moved to the static fire test. The static fire test was conducted at Sriharikota on 8th of August 2025.
The motor fired for 110 seconds with accurate nozzle deflection of 5 degrees, just as it was designed to do.
Having previously tested second stage and third stage of a rocket, we had now taken a big step towards the launch.
Stage separation is a high drama event, and with added complexity of upper stage nozzle protruding into the spent stage that needs to be pushed out. In May 2025, we put the integrated stages for separation on the test bed at our facility. In just 0.2 seconds, the stage 2 and stage 3 were separated, precisely maintaining that thin margin of few centimeters between the stage 3 nozzle and stage 2.
The payload fairing shields the satellite from atmospheric pressure and heat during the ascent. Once the rocket reaches vacuum, those concerns don't exist, so the PLF needs to be ejected out. As the PLF shell sits at the top of the rocket, they need to be separated away from the OAM, while the two shells also needs to be pushed away from each other. There's a lot of physics at play here, and it all had to be validated on the test bed, which is what we exactly did on June 7. PLF jettisoning success.
After all that raw power of ascent, it's the quiet, precise push of the OAM that guides the payload into its final orbit. Every major component was rigorously tested. The Raman 2 engine, our primary propulsion element, was tested for its full mission cycle. The Raman Mini and cold gas thrusters, which are used for fine-tuned adjustments and attitude control, were tested thousands of times. Even the avionics were tested and fully qualified, ensuring robust and reliable operation under the harsh conditions of spaceflight. Once all these systems passed these rigorous tests, we integrated and brought them together. The OAM is the mission's maestro, orchestrating tiny adjustments to ensure that everything reaches its intended orbit, giving us a flawless finale.
Test after test, every major system on Vikram 1 had qualified.
And with the successful completion of the integrated electrical test,
Vikram 1 was no longer just under development, and the next destination was clear: Sriharikota.
The moment we reach Sriharikota, everything changes.
In the past, we have been here for the Vikram S mission.
Now, after 4 years, we are back again.
This is the first time a launch pad at Satish Dhawan Space Center is hosting a private orbital rocket.
The launch campaign activities have begun, and with that, the timelines have also become super real.
Because now we are not preparing for a test, we are preparing for a mission Agaman.
Agaman means arrival in Sanskrit,
embodying the arrival of Vikram 1, a new Indian rocket in the global space market,
and the arrival of a new chapter of Skyroot.
Mission Agaman is about Skyroot, yes, but it's something even more.
It's a moment that gives flight to the ambitions of the Indian space tech industry.
Mission Agaman carries multiple test payloads, each one demonstrating critical technologies useful for the global space sector.
Graha Space is working towards developing an advanced constellation of Earth observation nanosatellites to stream near real-time geospatial video data.
At Cosmos of Space, we are building solutions for the space debris problem.
D-Cubed, a German company, is putting up a payload for testing their separation and deployment mechanisms.
We are building a dual spacecraft system, including a robotic spacecraft that goes to space, pick a dead satellite in space and pull it down. That is being demonstrated in this mission.
And these learnings are going to be used to build our future nanosatellites, which is going to be useful for the Earth observation applications.
Apart from these technical payloads, we have a miniature artwork paying homage to the giants of Indian science and technology field, such as C.V. Raman, Dr. Vikram Sarabhai and Dr. APJ Abdul Kalam. Together, these payloads represent different ideas, different technologies and different missions, all sharing the same right to space.
Staying true to our ethos of opening space for all, our test flight has payloads both from India and international customers. After all, our Vikram 1 rocket is a vehicle to advance all of our collective goals.
In less than a year of incorporating the company, we are standing here in the spaceport of India, integrating our hardware onto the launch vehicle.
By opening up the test flight to the startups, Skyroot is enabling the startup ecosystem as a whole.
Because building a satellite or an in-orbit platform is not just about perfecting that product, but also going through the rigors of flight qualification. From the outside, a rocket's flight is very brief, just a few minutes from liftoff to the mission completion. But a lot more goes into a mission.
This is our second mission and our first test to orbit.
The scale of Vikram 1 is much different than that of Vikram S. Being part of the first private attempt to reaching orbit is certainly exciting. The current pre-launch activities that are happening here already beat the record of the launch campaign for Vikram S.
We have just integrated the 3-stage solid motors along with the flex nozzle system. The next step is stacking them vertically at the launch pad.
Our goal at Skyroot is to build multiple Vikram 1 rockets and launch at a regular cadence.
These test flights will provide us the engineering and operational learnings that we can't get on the ground. Because a rocket's true and final test is the flight. And every flight teaches us what simulation cannot.
Mission Agaman isn't a destination,
it's a beginning.
Last November, our Honorable Prime Minister Shri Narendra Modi inaugurated our Infinity Campus in Hyderabad and unveiled Vikram 1 to the world. 8 months later, it's already on the pad. A company that started with 2 co-founders and an idea is now India's first space technology business to be valued at over $1 billion.
Today is significant for reasons that go beyond what it means for Skyroot.
For the first time, the first launch pad at Satish Dhawan Space Center is hosting a private orbital rocket. That's a first for the pad and a milestone for India's private space sector.
The people who helped make that shift possible inside India's space ecosystem, in policy, in industry, have been part of this journey too. Here's what some of them have to say.
India's space journey has inspired the world for decades. Now, private innovation is accelerating that journey further than ever before. The Indian Space Policy 2023 enables and permits the private entities to carry out end-to-end space activities through in-space. Today, Skyroot Aerospace represents India's bold new generation of space innovation.
10 years ago, I'm sure none of us would have imagined a private company building a rocket, taking it to the launch pad very close to the launch. And this historic moment is happening as we speak. Skyroot's Vikram 1 is ready to take off soon from Indian soil.
Vikram S rocket has been developed in a record time of 2 years from concept to the launch and has been built with advanced technologies like carbon composites and 3D printed thrusters.
It set the foundation for Skyroot's big leap to orbit by establishing Infinity Campus, India's largest private rocket factory. During the inauguration, Prime Minister Modi also revealed to the world a flight-ready Vikram 1, India's first private orbital rocket.
आज भारत के स्पेस इकोसिस्टम में प्राइवेट सेक्टर बड़ी उड़ान भर रहा है। स्काईरूट का इन्फिनिटी कैंपस भारत की नई सोच, इनोवेशन और सबसे बड़ी बात यूथ पावर का प्रतिबिंब है। आज पूरा देश देख रहा है, देश आप पर गौरव कर रहा है, गर्व कर रहा है।
Just like our smartphones are getting smaller, even satellites are getting smaller. And 90% of satellites which are set to launch in the next decade are all small satellites. And that needs rockets like Vikram 1, which can put small satellites to orbit. And Vikram 1 is more like an Uber to go to space.
Space reforms announced by Government of India just a few years ago were a big game changer for the space sector in India. It gave wings to companies like Skyroot. For the first time, innovative and ambitious companies in the space sector in India could dream big. The government also set up institutions to help Skyroots and other companies to fulfill these ambitious dreams. In fact, government itself set up an ambitious goal to take the space economy to $44 billion. And one of the very important part of that ambitious goal is to be a global hub for launching small satellites. And that's where Vikram 1 will play a very important role.
Standing 7 stories tall, Vikram 1 is capable of launching satellites of up to 350 kilograms to low Earth orbit.
Vikram 1, India will have a private rocket that can carry satellites to orbit, and our upcoming launch is our first step towards making a world-class launch solution available from India.
Today, the Hyderabad-based Skyroot company is targeting the first orbital flight using the Vikram 1 launcher. Towards this activity, ISRO has supported and carried out a lot of activity. This vehicle is a 4-stage vehicle with 3 solid propulsion stages and the upper liquid stage. And the first stage solid motor propellant casting was done in ISRO facilities. Also, the successful static test was carried out with the support of ISRO. The second stage and upper stage engine tests were carried out in the ISRO facilities. ISRO is also providing the launch pad, carrying out and hand-holding the activities including the vehicle assembly and accomplishing the launch-based activities.
With the opening of the space sector and the space sector reforms announced by the Government of India, we are seeing a transformative change that's happening in this sector. With the private space agencies, entrepreneurs, startups coming to fill the space in the domain of rocket building, spacecraft building and applications. This is really going to change this sector in India with its frugal engineering, cost-effective manufacturing capability that are already existing. And this specific area is being pioneered by companies like Skyroot. They have taken a huge responsibility of building rockets that can launch satellites into orbit. They are the pioneers.
Just as its rockets, the company too has skyrocketed. Today, Skyroot is valued at over $1 billion, making it India's first space tech unicorn.
Indian Space Research Organization cannot do everything under one roof, especially when the frequency of launches have to increase. And therefore, somebody like Skyroot is becoming really they're finding the foundation. They're making the foundation for the build-up of an ecosystem which will be required to sustain the frequency. And ultimately what's going to happen is that pure science and exploration will perhaps be the job of the government, while the logistics and the building up and the support which is required for these particular missions can come from the private sector. So I'm very happy that work has started. And as far as private companies, Skyroot, of course, is going to be the pioneer. Vikram 1 is going to be launched shortly. And they will be setting up that benchmark. And it's very heartening to see that they're opening their account with a launch of Vikram 1.
Skyroot is India's leading private launch provider, and Vikram 1 is fueling a new chapter for space exploration. Now, Skyroot is truly expanding the scope of India's space program. Of course, they're a trailblazer as a launch provider in the Asia region, in the global south, but they're also inspiring the next generation of engineers and explorers who now dream of contributing to a team like Skyroot, or even founding the next startup of India thanks to Skyroot's leadership.
With Vikram 1, not only will we be able to launch small satellites at very affordable prices, but also create an ecosystem around it that will help to manufacture and design the satellites, the small satellites, and also to get into after launch activities like data reception and applications. So I'm really excited to see what Vikram 1 will do for our space economy.
The potential of this sector is in bringing businesses to this country. For example, what is happening in the world, especially in the US, the increase in number of the launches, increase in number of the spacecrafts to orbit, especially constellation launches, really gives possibility for low-cost operation of these rockets in numbers. With sufficient number of satellites being built in this country for satisfying the launch service market. I think this is a great opportunity presented in front of us. I'm sure this sector will scale with the building of small satellites in large numbers in this country to serve the sectors like communication constellation, Earth observation constellation, as well as PNT services constellations, including IoT and others. To meet all those launch demands, I think we need to have more rockets in the market. I'm very sure that Skyroot is going to fill that space in a substantial manner because of their frugal engineering, low-cost approach, and very high reliable builder character. I think this is really going to change the sector in a big way.
The collaboration between Axiom Space and Skyroot was founded in this shared vision of opening access to space for more nations around the world. And so there is significant value in combining Skyroot's launch capabilities with Axiom's station infrastructure and also mission expertise to open up this access to the space environment and the microgravity environment. And why this is so important is because if we can have more access to space, then more nations, more companies, and more researchers can reach the benefits of space and the benefits of microgravity and bring those benefits back to all the people of Earth.
Those voices put into perspective what today means for our company and the global space industry.
But Skyroot's story is a human story as much as it is an engineering one. And one of our colleagues spent some time talking to people from different teams, different roles, and different experiences. Over to you, Trunika.
Behind every subsystem, every review, and every milestone, there's a team. Hi, I'm Trunika, and today I'm speaking with different team members at Skyroot about their work, their experiences, and what this mission means to them. What made you want to work at Space Tech instead of the usual jobs your batch was going for?
But I wanted to work on something where every design and material decision is critical and has a vital role to play for mission success. That's when I came across Skyroot, and the most exciting thing about Skyroot is to contribute in a launch vehicle as a materials engineer in a team which is shaping the future of Indian private space sector.
So it's been 2 months since I joined Skyroot. Before I joined Skyroot, I was very much excited to work at a space tech company. But what I was not expecting is to witness the launch mission so closely. Like, I was amazed with the journey. What amount of hard work, dedication, consistency, and teamwork is required for a launch. There is a complete different story behind the launch.
One thing people outside probably don't see is that we just don't talk about the mission. We genuinely believe in it. And that's what makes our team special, because we all know we are working towards something that is much bigger than ourselves.
What strikes you immediately after a few conversations is how quickly people stop being new and become integral to Team Skyroot. If you had to explain your part of the rocket to a 10-year-old, what would you say?
So, avionics is like the nervous system of the rocket. Without it, the rocket cannot talk to us and does not know how to fly. It helps the rocket know where it is and make important decisions in every situation so that it can safely reach its destination.
One thing people don't realize is that there is no space for errors. Before we move on to the next step, we always test and validate data of the component multiple times, and that takes lots of patience.
While not everyone here works on Vikram 1, everyone here is working on the mission.
Earlier, I used to think that the rocket launch is the biggest event in a rocket's journey. But being behind the camera and experiencing the process over years, I learned that there is so much that goes behind the scenes. And honestly, witnessing this journey has been exciting.
What does a day in your role actually looks like in a company that's still known mostly for engineering?
See, as it should be. Without the exceptional talent, hard work and innovation of the engineering team, there is no business. My role is to take confidence from the work that they are doing, communicate and translate that when I'm working with our customers. But it's also a two-way street at the same time, right? I take the requirements and the needs of the customers and the market, translate that so that the engineering team can come up with the solutions for those future demands.
So now when I see Vikram 1
all ready to go. It feels very numbing and also very honored that I got a chance to work on this amazing vehicle.
I truly feel fortunate and proud to be a part of this launch mission. And this is a moment that I'll always cherish.
See, ultimately, the goal is not to build an amazing piece of technology that just goes into a museum or the history books. What we are trying to build is a long-term, reliable, and sustainable business to meet the demands of the future space economy. And for that, I think Skyroot, the business team, and our customers are going to start with the low Earth orbit, but we are ready to reach the stars.
Every conversation I've had today has been different, but there are a few people who have had a front row seat to this entire journey. Now let's hear from them.
It has been a great journey. I saw engineers run through lakhs of simulations and hundreds of designs and configurations to make an optimal vehicle design.
Seeing so many passionate people joining us to build something incredible, not only for us, but for the nation. Interacting with them day in, day out, grooming their talent, nurturing their growth, makes this more than a job.
You know, the story really isn't about the rocket. It's about a generation of Indian entrepreneurs, builders and dreamers and their potential. The rocket just happens to be a proof of that.
Skyroot is frontrunner in India's new space ecosystem, and our launch essentially signifies that the ecosystem has matured to a level where it can produce products and services that can compete well on an international arena.
Attention to quality is top-notch in rocket science. Our engineers spend thousands of hours in validating, testing, which generally go unnoticed, and people only see the outcome of the launch.
Foreseeing things and to handle schedules, permissions, allocations, etc. is what we are prepared for.
The fact that we are at the launch pad is a great milestone in itself, and my phone has been ringing non-stop. For the customers who signed up with us, it signals confidence, and for the prospectives, they're experiencing this mission with us, and I'm excited about the conversations that happen tomorrow.
Whether they have been here for years or just have started, one thing has been common in every conversation I have had. Everyone's hoping for the very best for this mission.
I'm really hoping that everybody who worked on this watched their dream lift off to success.
I'd love to see today's data confirm everything we've spent years designing, testing, and validating.
Here's hoping and wishing that today marks beginning of many successful launches and great partnerships with our customers across the globe.
I wish our mission is successful and all our hard work pays off.
My wish is simple. Everything we have prepared for last few years comes together seamlessly.
I wish Vikram 1 to be a huge success and make India and Skyroot proud.
Here's hoping today's launch provides us the required learnings to attempt more frequent launches and build much bigger rockets.
I would really like everyone to soak in and enjoy this moment.
I hope everyone feels proud today.
I hope everyone sees a little bit of themselves in today's launch.
Hey guys, it was all worth it.
And as we all say at Skyroot, our people are our thrust and you are the thrust which made this happen. Let's all work together and create all the out-of-the-world milestones going forward.
Today also features a few guests whom we've invited to witness this launch with us. So let's hear from them.
Namaskar. I know today is a landmark day. Skyroot stands at the cusp of their first orbital launch. Not just Skyroot, India stands at the cusp of their first orbital rocket launch from the private sector. Being a test pilot and then an astronaut, I know maybe a little of how it feels. How does it feel when you are trying to validate your years of dedication, preparation, and hard work? I know a lot of you would be anxious. A lot of you would be excited. But I would urge you to choose excitement. To me, I feel that this is a defining moment for India's private space ecosystem. A rocket launch to orbit is just a symbol of the rising aspirations of India as a nation in the space sector. And I wish the team the very best.
Vikram 1 is going to be launched shortly, and they will be setting up that benchmark. And it's very heartening to see that they are opening their account with a launch of Vikram 1.
So I'm really excited to see what Vikram 1 will do for our space economy.
This is really going to change the sector in a big way.
Wish you all the success as we move forward from the first launch to dozens and dozens of launches that will follow very soon. All the best.
On behalf of the Department of Space, let me extend our heartiest congratulations to the young Skyroot team and also my team members who have supported this activity.
All the very best to you and keep working hard to achieve all your dreams. Thank you and once again congratulations to the entire team of Skyroot.
Vikram 1 is carrying more than hardware into orbit today. As this mission came together, Skyroot reached out and invited people to send their wishes into space. Not a message, not a post, a postcard. Something physical, something personal, going all the way into orbit.
And one of those postcards was signed by our Honorable Prime Minister Shri Narendra Modi. Here's our CEO and co-founder Pawan on that moment.
I'm right here at Sriharikota at the launch site, and we have these special cards which we received from our team members, our investors, policymakers, and all well-wishers across the country. And we also have a very special card from none other than our Honorable Prime Minister Narendra Modi ji. And reading this gives me goosebumps. He has written Vande Mataram. And all these cards are going to go to space on Vikram 1 Agaman mission, and very excited to send them to space.
Every postcard the vehicle has on board carries a name, a signature, and a wish.
The Skyroot team has sent in their cards too. Their words are going to space on India's first private orbital rocket.
And now is the moment we all have been waiting for.
We are about to hand you over to Sriharikota, where the launch team has been through the final checks the previous night. Vikram 1 is finally ready for liftoff.
In just a few moments, you'll be watching a private Indian rocket attempt to reach orbit for the first time from the first launch pad and from Indian soil.
Thank you so much for being with us, and our team at the spaceport will join you live soon. So, stay tuned.
Hello and a very warm welcome to everyone joining us from across India and around the world. I am Suyash Abhay-Ghirnikar, a program manager for liquid propulsion team at Skyroot Aerospace, and we're coming to you live from the Satish Dhawan Space Center at Sriharikota, where the countdown is underway for the maiden test flight of India's first private rocket, Vikram 1.
It's really wonderful to have you with us for what promises to be a truly historic day for India's space sector. I am Vaidehi Bhoyer, an aerothermal engineer at Skyroot Aerospace. Vikram 1 embodies years of focused work spread across 15 plus cross-functional teams at Skyroot Aerospace. And sitting here in MCC, we are extremely thrilled to see it stand on the launch pad today.
जी हाँ, यदि आप अंतरिक्ष विज्ञान में रुचि रखते हैं या आप एक विद्यार्थी हैं या बस आज इस मिशन को लेके उत्सुक हैं, तो हम अत्यंत आभारी हैं कि आप इस समय हमारे बीच सम्मिलित हुए। मैं अखिल तेलंग, स्काईरूट अंतरिक्ष विभाग में घूर्णी यंत्र अभियांत्रिक आपका हार्दिक अभिनंदन करता हूं। और बस 30 मिनट के अंदर हमारा ये सारा परिश्रम उस क्षण में परिवर्तित हो जाएगा जिसकी हम सबको प्रतीक्षा थी, विक्रम 1 का प्रक्षेपण या लिफ्ट ऑफ। अब हमारे समक्ष मिशन नियंत्रण केंद्र के अद्भुत दृश्य दिखाई दे रहे हैं, जहां पर विभिन्न प्रकार के विभाग अपने अपने प्रणालियों का संचालन कर रहे हैं। और इस प्रसंग में हमारे साथ डॉक्टर जितेंद्र सिंह जी, माननीय मंत्री स्वतंत्र प्रभार विज्ञान और प्रौद्योगिकी तथा अंतरिक्ष विभाग, मिनिस्टर ऑफ स्पेस भी जुड़ने वाले हैं। और यहाँ स्काईरूट दल का उत्साहवर्धन करने के लिए हमारे साथ डॉक्टर पवन गोयंका जी, माननीय अध्यक्ष भारतीय निजी अंतरिक्ष प्राधिकरण इन स्पेस, और डॉक्टर वी नारायण जी, माननीय सचिव अंतरिक्ष विभाग और अध्यक्ष भारतीय अंतरिक्ष अनुसंधान संगठन ISRO भी हमारे साथ इस विशेष क्षण के लिए मिशन नियंत्रण केंद्र में उपस्थित हैं और स्काईरूट टीम का उत्साहवर्धन कर रहे हैं।
That's right, Akhil. It's so wonderful to have so many dignitaries join us. We have Director Shar on screen along with Pavan and Bharat. And recently you just saw live views from the launch pad as well. And we're going to take you live over the next half an hour, right down inside the countdown, tell you what's happening behind the scenes, and take you through every major milestones. On your screen right now is ISRO Chairman Dr. V. Narayanan alongside Pavan Goenka sir. And like we mentioned, this is the first launch, first test flight for Vikram 1, and today essentially is a chance to see how the vehicle really performs, gather as much data as we possibly can. And it's important to note that this is one of the first several flights before we get into routine commercial operations. So wherever you're joining us from, please settle in, count down with us for what could be a defining moment in India's space sector.
अवश्य सुयश, विक्रम 1 इस समय प्रक्षेपण मंच पर स्थित है और अपनी प्रथम परीक्षण उड़ान के लिए तत्पर है। किंतु रॉकेट के बारे में जानने से पहले आइए जानते हैं स्काईरूट की कहानी। तो स्काईरूट एरोस्पेस की कहानी हैदराबाद से प्रारंभ होती है, जो पूर्व भारतीय अंतरिक्ष अनुसंधान संगठन के 2 वैज्ञानिक पवन कुमार चंदना और नागा भरत ढाका के एक साहसी विचार के साथ जिसकी स्थापना की गई, जो था अंतरिक्ष को सबके लिए सुलभ बनाना या ओपनिंग स्पेस फॉर ऑल। आप सभी इस यात्रा का काफी समय से भाग या हिस्सा रह चुके हैं, तो अपने अपने अनुभव के बारे में थोड़ा दर्शकों को बताइए।
Right, Akhil. Thank you for asking that. So back then in 2018, when I heard about Skyroot, it was really a mix of excitement and curiosity. For decades, India had looked up to ISRO for every space milestone. India's space sector was opening up to private participation, creating room for companies like Skyroot to innovate, build, and contribute to the nation's growing space ambitions. Here was a private company which came out of nowhere and it said, "We are going to build an orbital launch vehicle from scratch." On immediate thought, it looked like this is going to be extremely difficult. But if anyone succeeds, it could actually redefine India's entire space ecosystem. It felt bold, it was quite ambitious, and the timing felt quite right. Suyash, what did you make of it?
Yeah, Vedi, it was pretty mind-blowing to say the very least. When we first heard about this, it was extremely exciting. One question that we asked ourselves is, we have such a grand vision, but what do we need to do on ground before we can aim for stars? So one thing we realized very early on is every critical piece of technology that we need to fly, we need to test in-house, we need to build in-house. And I got the chance to help build a lot of these technologies. So me with a small team of very ingenious, multidisciplinary engineers, we essentially helped build the liquid stages on this vehicle. And working from the ground up, designing and testing the upper stage, the RCS module, sort of taking it from cradle to grave was a once in a lifetime opportunity that we knew that we had to capitalize on. And like where they said, the timing was everything, because the entire space sector was about to take off.
Yeah, perfectly put, Suresh. I mean, if you look at way back in 2018 when Skyroot was founded, we had just handful of space companies, and now in like close to 2020 we had almost 100, and in 2026 India finally has its first space tech unicorn, and almost close to 350 plus space companies. So I think it's apt to say that Skyroot has pioneered India's private space ecosystem.
Yeah, that's true. And just recently you were seeing views from the launch control center of Skyroot, and now on your screens is the mission control center, where we have a lot of dignitaries who've joined us. On your screen right now is Pavan and Bharat, and of course Sanjay as well, our mission director. So one of the things that Akhil just mentioned is that it's pioneering the space ecosystem. One thing that comes about is the space market is growing just as rapidly. Space has quietly become part of our daily lives. Every weather forecast that you look at, every map that guides you home, digital payments that you make every day, long distance calls. Each of these have a satellite essentially working in the background, making all of these possible. India's space ecosystem today is worth $8 billion. And we're expecting, the government essentially wants to make it a $40 billion market by 2033.
All stations.
And all of this is a part of global hierarchy. The global market also is inching towards $1.8 trillion by 2035. And it's a market which is growing twice as fast as the global economy itself. And the biggest drivers are here on Earth. We have precision agriculture, farming. There are satellites in space essentially which can capture things which the human eye cannot see. And all of this just presents huge advantages to working for space to make life better on Earth. So, Vedi, I understand you were part of the team that built the first rocket for Skyroot. So, what was that journey like for the engineering teams from development through to launch?
Suyash, now that I think about our first launch, it was really an amazing experience. We had no idea of what rocket science is, and it was a really great chance to understand that a rocket is essentially made up of hundreds of small subsystems which are really interconnected. And to make a mission or a vehicle successful, they have to work perfectly in sync. So that whole process of understanding that, oh my god, this is actually rocket science, it was amazing. And mission Praram in 2022, I'd say it was far more than just a rocket launch. It was the maiden flight of Vikram as India's first privately developed rocket. Fittingly, Praram means a beginning in Sanskrit. And for the young engineering teams involved, it was once in a lifetime opportunity to work hands-on with cutting-edge space technology, build systems from the grounds up, make rapid engineering decisions, and take ownership of the critical subsystems. And it was really, really amazing to see that kind of a collaborative effort pay off. The mission was highly successful. It crossed 89 kilometers, achieved all its planned objectives, and I feel like that event, in a true sense, marked the dawn or the praram of India's private space era.
That's really inspiring, Vedahi, and what a perfect way to put it. I mean, and now let's come back to today, and we are getting inputs from the ground station teams that just a couple of hours ago, they have completed a very important step. They have gathered the wind profile data for the launch day, and as we are seeing here, it's slightly cloudy. We had rains last night a little bit. So these launch wind data are captured using Doppler weather radar, and the wind profiles will be then analyzed and will be updated in the program before loading it to the mission computer for the ALS.
Yeah, that's right, Akhil. And this is such a unique step in the launch vehicle program where we collect day of launch winds. Like you mentioned earlier, that it's a bit cloudy today. The whole goal is the strong winds that come about in upper atmosphere or lower atmosphere are capable of nudging the rocket off its course. And so making these adjustments essentially just helps you correct and make sure that you stay on the planned trajectory. So one thing that our viewers are also very curious about is we called our first mission as Mission Praram, that Vedi talked about as well. So the question is, what have we called this mission as? And we're very excited to tell all our viewers that we've called this mission as Mission Agaman. The word Agaman is derived from the Sanskrit word meaning arrival, and it's sort of twofold. The first is it's the arrival of India into a new space era, wherein the private sector takes a huge leap and delivers and caters to the global launch market. But secondly and importantly, it's the arrival of a new launch vehicle, a very capable launch vehicle, to the launch market and help meet some of that global demand. Now, something pretty cool about today's date, and I assure you it's purely coincidental, and it's kind of amazing really, is 46 years ago today, India's first indigenous launch vehicle, SLV, reached space and placed the Rohini RS-1 satellite in orbit and kicked off India's space ambitions. And coincidentally again, 8 years ago today, Skyroot began its journey as well to open space for all. So it's company day today as well.
अवश्य सुयश, इस जानकारी को दर्शकों को प्रदान करने के लिए आपका धन्यवाद। अब हमारे समक्ष हम देख सकते हैं स्काईरूट के प्रक्षेपण नियंत्रण केंद्र के प्रत्यक्ष दृश्य, जहां प्रणोदन, यंत्र विद्युत, दिशा निर्देशन नियमन जिसको हम गाइडेंस नेविगेशन कंट्रोल, ऊष्म वायुगतिक जिसको हम एरोथर्मल, सुरक्षा और यान प्रतिकरण जैसे कि सेफ्टी और सेपरेशन डायनामिक्स डिपार्टमेंट से जुड़े विशेषज्ञ दल यान के प्रत्येक अवस्था पर निगरानी और दृष्टि रखे हुए हैं। ये वही केंद्र है जहां पे प्रक्षेपण की हर महत्वपूर्ण प्रणाली की मुख्य पुष्टि करी जाती है। और अब आइए जानते हैं इस सुबह के प्रमुख नायक विक्रम 1 के बारे में।
Right, Akhil. So Vikram 1 is Skyroot's first orbital launch vehicle built specifically to carry small satellites into orbit. It stands 22 meters tall, 1.7 meters in diameter, and its gross lift-off weight is 45,000 kgs. Its first three stages are powered by solid rocket motors. They provide the enormous thrust needed to lift the vehicle up through Earth's atmosphere. The first stage alone develops around 1200 kilonewtons of thrust, roughly 10 times compared to that of a Boeing 737 MAX engine. And that's how the engines get their names. The numbers are the thrust, and they honor Dr. APJ Abdul Kalam. Kalam 1200 for the first stage, then Kalam 250 for the stage 2, and then Kalam 100 for stage 3.
जैसा कि वेदी ने जानकारी प्रदान करी, विक्रम 1 स्काईरूट का प्रथम कक्षीय प्रक्षेपण यान है जो छोटे उपग्रहों को उसकी कक्षा तक स्थित करने के लिए निर्मित किया गया था। इसके पहली 3 अवस्थाएं ठोस प्रणोदन द्वारा संचालित की जाती हैं जो यान को वायुमंडल के पार ले जाने के लिए अत्यंत आवश्यक प्रबल प्रणोदन बल प्रदान करती है। और अब अंतिम इसका चरण, जिसको हम कक्षा समायोजन खंड, जो कि ऑर्बिट एडजस्टमेंट मॉड्यूल के नाम से भी जाना जाता है, वो द्रव्य प्रणोदन पर आधारित है और उपग्रहों को सटीक कक्षा में पहुंचाने के लिए अत्यंत सूक्ष्म नियंत्रण प्रदान करना इसका कार्य होता है। और ठोस प्रणोदन प्रणालियां जो हमारे स्काईरूट के इंजन्स हैं, वो उसका नामांकन डॉक्टर एपीजे अब्दुल कलाम के सम्मान में हमने समर्पित किया है। और द्रव्य प्रणोदन प्रणाली के इंजन के सभी नाम, उनका नामांकन डॉक्टर सीवी रमन के सम्मान में हमने समर्पित किया है।
Yeah, that's right, Akhil. You just earlier mentioned the orbital adjustment module. It's one of the liquid stages that we've developed. It has 500 plus components that have to work in unison. It's a very complex stage, and it's powered by liquid propulsion. It differs from the solid propulsion in the sense that it doesn't generate enormous amount of thrust, but it has a certain amount of precision that is only possible with liquid propulsion. So that's where we use the OAM stage for precise adjustments to the trajectory. And that's not the only place where we use liquid propulsion systems. We have an interstage on the vehicle which sits between stage 2 and stage 3, and its whole job is to provide roll control for the vehicle during its ascent phases.
And all those liquid engines are powered by hypergolic propellants, right, Suyesh?
Yeah, that's right. So we use something known as MMH and N2O4. These are two chemicals. They're stored in separate tanks. And the way they work is when you bring them in close proximity to each other, they spontaneously combust. Of course, you need a certain threshold concentration. The whole advantage is then you don't need an ignition system. So you've deleted a failure point, a potential failure point out of the system. So it's kind of unique and useful as well.
That's really interesting to hear, Suresh. And coming back to steering of a rocket engine, for the information of all of our viewers, so this is a rocket model that I'm holding in my hand. So if you suspend it in the air or space, we can say, it has unconstrained 6 degrees of freedom, out of which like 3 are straight line motion, or let us say translational, in which it can move forward, backward, upward, downward and sideways, and 3 degrees of rotation are rotational, which we call as pitch, yaw and roll. So these are the 3, or let us say mechanisms that are like, we can say, help in steering the rocket engine and the entire vehicle in the sense.
That's right, Akhil. And I believe different parts of the vehicle handle different pieces of that. So on the way up, the solid rocket motors steer in pitch and yaw by swiveling their nozzles. Roll, which is the spin around the rocket's own axis, is handled separately by a small dedicated liquid system during the climb. We have a set of 4 thrusters which fire in pairs to control the roll of the vehicle. And once in space, OM does its own pointing with the help of small thrusters, which Suyash will tell us about.
Yeah, so on the OAM stage, on the periphery of the stage, we have what we call as Raman mini thrusters. So they essentially generate 50 newtons worth of thrust, and they help in attitude keeping, which is essentially making sure that the spacecraft points in the right direction. So that covers the pitch and yaw. What do we do about roll, one might ask? So we have like these small cold gas thrusters. They're placed along the periphery of the stage as well, and they fire in pairs. So with that, they're capable of generating a rolling moment to roll the vehicle. Now, this whole architecture that we talked about, it's something that answers purely to the requirements. It's powerful where it needs to be and incredibly precise where accuracy matters the most. And this is a philosophy that we've extended beyond propulsion. So all our structures on the rocket are made out of carbon fiber. This is India's first launch vehicle, which is made purely out of carbon fiber. And it's 5 times lighter than steel. We also employ advanced propulsion technologies. All our liquid engines are additively manufactured or 3D printed. And all of this, what it contributes to is it reduces the weight, it improves performance, and also increases manufacturing efficiency. The net sum of all these decisions is you have a rocket which is reliable, on demand, and affordable.
That's true, Suyash. So, an update for our viewers. Just a while back, we got a confirmation that the guidance, navigation, and controls team, they have successfully completed gyro compassing and the static navigation profiling of the lens package. This is done so that the rocket knows its initial orientation with extremely high accuracy. In the process, the inertial navigation system determines the initial attitude of the vehicle by identifying the true north and the gravity direction with respect to a rotating Earth reference frame. So quite unique it is.
That's true. And it's something very important for you to know where your orientation is before you make that journey to stars. It's sort of like using a compass when you're going out camping. You want to know where north is so that you can chart your journey accordingly.
जी सुयश, और आई थिंक वायुयान में भी इसी सिद्धांत का प्रयोग किया जाता है और वो उसी सिद्धांतों पर निर्भर करती है। तो यदि अब हमको ज्ञात है कि रॉकेट किस दिशा में जा रहा है, हमारा विक्रम 1 प्रक्षेपक यान, आज की इस पूरी यात्रा का लक्ष्य क्या है, वो किस ओर प्रस्थान करेगा?
Today's test flight is attempting a 450 by 450 kilometers circular low Earth orbit or LEO, a region of space widely used for Earth observation, communication, and technology demonstration. But this is a maiden test flight. So what matters most today are the fundamentals. Today's test flight has 3 prime objectives: executing successful stage 1 ignition and liftoff, clearing the launch tower safely, and then gather as much data as possible from our onboard sensors.
अवश्य विदय, जैसा आपने कहा कि ये एक प्रथम परीक्षण उड़ान है, इसीलिए आज सबसे अधिक महत्वपूर्ण ये है कि अभियान के प्रमुख उद्देश्य को हम जान लें। प्रथम चरण का सफल प्रज्वलन, यान का सुरक्षित उड़ान पथ से निकास और अधिक से अधिक उड़ान अंकों का संकलन। किंतु अंतरिक्ष तक पहुंचना अत्यंत महत्वपूर्ण है, ये हम सब जानते हैं, बट सही कक्षा में उपग्रहों को स्थापित करना एक कठिन कार्य है, राइट?
That's absolutely right, Akhil. It's not sufficient to just simply reach the right altitude. The rocket must inject the payload with the correct velocity, the right flight path, and the precise orientation so that the satellite begins its mission exactly as planned.
Yeah, that's right. Now that we know where Vikram 1 is headed, let's talk a bit about what it's carrying today. So what's on board today's mission?
Vikram 1 is carrying 2 deployable test satellites today. The first one is Scope, a test satellite developed in-house by us as a technology demonstrator. Joining Scope on today's mission is Solaris, a CubeSat developed by Aerospace, flying again as a technology demonstration payload. And from Germany, D-Cubed is testing 2 of its own systems, deployment and suppression technologies built to work in orbit.
And there is one more interesting payload that we have is from Cosmoserve Space, and it's flying soft robotic arms along with the OEM stage that will attempt to capture a piece of simulated debris in orbit. That is a very interesting thing that they're attempting indeed. And it stays mounted to Vikram 1 throughout the entire flight. And if it works, it will be the first of its kind to demonstrate this kind of a experiment. And it's an early step to clearing the space debris in general. That's a great initiative, I think.
Yes, definitely. And there's 2 more payloads on board, ones that celebrate creativity and India's scientific heritage. The first is Cosmic Bloom, a delicate floral diamond artwork from Cosmos Diamonds. The second is quite something else entirely. It's a micro art, an 18-karat gold rocket crafted by Telangana artist Ajay Kumar Matewada, holding 3 tiny sculptures. of Nobel laureate Sir C.V. Raman and visionaries Dr. Vikram Sarabhai and Dr. APJ Abdul Kalam. Each one of them is smaller than a grain of rice, and it's a fitting tribute because all these three names essentially live aboard Vikram 1 itself. The Raman engines, the Vikram 1 vehicle, and the Kalam motors. Now, as we count down, of course, it's worth taking a pause to appreciate where this journey is beginning from. Vikram 1 lifts off from the first launch pad here at Satish Dhawan Space Center at Sriharikota, more familiarly called as the Shar Range, a place that has witnessed some of the most defining moments in India's space program.
That's correct, Suyesh. This very pad has a proud history and legacy of its own. This is the exact place where Mangalyaan set off for Mars in 2023. And Sriharikota itself has launched India's greatest space journeys, like Chandrayaan to the moon, Aditya L1 to study the sun. And now, our very own Vikram 1 adds its own chapter on its journey to the stars.
That's right, Akhil. Missions like Vikram 1 are helping position India to serve the fast-growing global demand for small satellites, and they reflect a wider momentum as well. Under national initiatives championed by Honorable Prime Minister Narendra Modi ji, Make in India, Atmanirbhar Bharat, Skill India, this country has been building exactly the kind of indigenous innovation, advanced manufacturing, and high technology skill that a vehicle like this is built on, and which is why today's mission is of utmost national importance.
Yeah, and in some of those initiatives that you mentioned, we also have Gati Shakti, which has essentially eased the way we get approvals and get things done. For what could used to take years on end, now is simplified to a matter of minutes just sitting at home.
अवश्य, किंतु उस तीव्र गति और तीव्र प्रगति का बड़ा भाग एक महत्वपूर्ण मोड़ से जुड़ा है, जो कि 2020 में ऐतिहासिक अंतरिक्ष नियमों के परिवर्तन के परिणाम स्वरूप जो इन स्पेस संस्थान की स्थापना हुई थी, और इस संस्थान का कार्य शासन तंत्र और निजी अंतरिक्ष क्षेत्र के मध्य एक समर्थ, सुगम और दूरदर्शी सेतु की स्थापना करना था, जो कि काफी कठिन कार्य है। और स्काईरूट जैसी सभी संस्थानों की ये यात्रा को सशक्त और आधार प्रदान करता है। इसीलिए हम इन स्पेस के प्रति हार्दिक कृतज्ञता व्यक्त करते हैं।
That's right. We have live on our screens views from the launch gallery where hundreds of students, actually thousands of students, have joined us on this historic mission. These are the people who are the future of our nation, and we encourage them to join us on this journey with us to the stars. Take up projects in future which contribute to the space sector and the national space ecosystems as well. Now that we've explored the significance of today's mission, let's take a closer look at what Vikram 1 is about to do in a few minutes. Of course, Vikram 1 will lift off and ascend vertically from the launch pad before executing a pitch over maneuver, and from there it will gradually transition into what's known as a gravity turn.
That sounds a little counterintuitive, and if the launch vehicle is headed straight to space, then why does the rocket just keep not going straight up?
That's a great question, Akhil. While gaining altitude is important, reaching orbit is all about building horizontal velocity. The gravity turn allows the rocket to efficiently accelerate around the Earth rather than simply away from it, using less propellant while achieving the velocity needed for orbit.
Event number 104.
Yeah, and we've just heard callouts from the Mission Control Center that the automatic launch sequence has been activated. It's one of the preliminary starts to the program and a very important point. At this point, the countdown is now fully automated with hundreds of onboard commands executed in precise sequence, leading us to liftoff.
And although the process is entirely automated, I believe the mission teams are closely involved, right? They have to ensure that every system is operating at its nominal health conditions.
And correct, Vedai, if any one of the many critical parameters that we observe during the entire sequence goes out of its nominal expected bounds, then the rocket smartly aborts the entire sequence and initiates a preloaded set of commands, and that will safeguard the entire vehicle, and then the people stationed at the ground or the engineers can have a closer look, and if the issue can be resolved within the stipulated time, then we'll have the sequence back again and we can go ahead with the launch.
Yeah, that's right. This is something very useful to have wherein engineers can resolve faults and understand if there's something that can be quickly fixed, and then we can continue back on ALS. So I think we were just talking about what the rocket does, and once stage one powers the vehicle for nearly 100 seconds, something important comes, which is max Q.
Right, you're right, Suyash. As the vehicle continues to pitch over and accelerate, it approaches one of the most demanding phases of ascent. Nearly 25 seconds into the flight after the gravity turn is max Q, the moment of maximum dynamic pressure. This is when the rocket experiences the greatest aerodynamic loads, a true test of its structural strength and engineering precision.
Yeah. So now we're at T minus 9 minutes and we're entering another crucial phase of the launch countdown. The launch team is now carrying out a final series of vehicle health checks and making sure that Vikram 1 is fully prepared for flight.
Yeah, as we can see on our screens, one of the most key milestones at this stage has been completed. That is the transition from the external ground power to the rocket's onboard batteries. Up till now, the vehicle has relied on its own ground support systems, but from this point forward, every stage must successfully power itself. And engineers are closely watching the battery performance and electrical health to ensure that this transition is very smooth and every system remains entirely stable.
Right, Akhil. With the power transition complete, attention would shift to the rocket steering system. Engineers will now be verifying that the thrust vector control, or the actuators as we call it, the mechanisms which steer the rocket by precisely directing thrust through powered flight.
Yeah, and you mentioned these actuators. Essentially, all of our solid rocket motors are equipped with what is known as a flex nozzle control. Sounds like a bit complicated term, but it's quite simple. It's just the nozzle is capable of swinging in two planes, and the way we achieve this motion is by using electromechanical actuators. So you might imagine that this is something very important that we should check. So what engineers do is they perform something known as a null check. Essentially, they currently try to hold the nozzle in a neutral position. And then once that is confirmed, they provide small commands to the nozzle to deflect it. And if the response is deemed to be normal and the position is correct, we can be rest assured that the rocket will obey every command that is issued to it by the guidance computer. All right, live on your screens right now is the Vikram 1 rocket. And for a long time now, we've been looking at these views, and the biggest thing that comes out to our mind is, wow, that's a marvelous piece of engineering. And it's actually rocket science, right? There's a nearly 1,000 systems that need to work in perfect synchrony just to make liftoff happen. And that's 2/3 of all systems on rocket. So 2/3 of all systems on the rocket need to work perfectly to make liftoff happen. And while it's so easy to look at the rocket and be amazed by its beauty, we would like to take a small pause and focus on the fact that behind every bolt, every wire, every line of code that is on the rocket today, it's been built by people whose passion, perseverance, and dedication have made this moment possible. Of course, a launch vehicle is never built overnight, and it's the result of countless people obsessing over one thing to make it perfect.
Exactly, Suyash. We often celebrate rocket launches, but rarely appreciate the engineering complexity behind that. And the most primary guiding principles in Skyroot is our people are our thrust. So it's not just the rocket alone that pulls the company up. It's just the people that pushing forward, pushing the entire technology forward, and all that hard work. So Vedahi, after working on an orbital launch vehicle yourself throughout these years, what has been your biggest realizations in designing the rocket?
So one of the most important realizations which I've had is, as Suyash also mentioned earlier, rocket consists of almost around 1,000 independent subsystems, and they are deeply interconnected. A seemingly small error in one discipline can propagate through multiple subsystems and ultimately jeopardize the entire mission. Rockets operate with extremely tight margins, so local design inaccuracies rarely remain local. This interconnectedness is precisely what makes launch vehicle design both extraordinarily challenging and intellectually rewarding. Each deviation might appear acceptable individually, but they can also collectively, they can all consume all the design margins available.
Yeah, so we have a planned hold at this point. As you might see on your screens, the timer is paused at 5 minutes. So we will be checking with the internal teams, and we'll get back to you with the countdown shortly. All right. While we wait for this countdown to resolve, there's so many cool facts about space, and something really fascinating that always catches me is when Vikram 1 races through the atmosphere, it's not just fighting gravity, it's also battling extreme aerodynamic heating. And one thing that's always curious is why is the rocket heating up while it's going up in the atmosphere?
Right. So, as we are accelerating into the dense atmospheres of Earth with velocities almost 3 times, 4 times that of sound, the air in front of the vehicle rapidly gets compressed, and just outside the vehicle surface will have extremely high temperatures, which then get convected into the vehicle surface. So, just a simple question: do you guys know like what is the heat flux which we face standing on the Earth's surface due to the Earth's radiation?
I think 1000 watt per meter square, kind of. Am I right?
That's right. That is 1000 watt per a meter square. It's around 0.1 watt per centimeter square. When Vikram 1 ascends into the Earth's atmosphere, its nose tip can face around 15 watt per centimeter squares of heat flux.
That's pretty large, I mean, as compared to humans. If we, yeah.
That's right, that's right. And we really need to design a thermal protection system to keep the structural design under the set constraints. If we don't design any thermal protection system, the vehicle surface might end up going to 1500 degrees Celsius. And
Control to all stations. There is a hold observed at T-5 minutes. All stations are requested to be on standby mode.
We have received confirmation that this is a planned hold and we've been advised to stay on standby. We will communicate regular updates to you, so please stay tuned with us. Can you check if they can queue us and we'll talk trivia?
ट्रिविया वाला खोल दो एक बार कहाँ
I don't know if the last trivia went through.
एक सेकंड टाइम लगेगा रुक जाओ
So just for safety sake, we'll do the next trivia, which is
होल्ड
Kalam.
कलाम वाला
Like the names.
वो ऑलरेडी बोल दिया ना
I don't know if it went through, so I don't want to repeat.
ओके ओके क्या बोलेगा तू क्या बोलेगा ये
कलाम
पर मैं ऑलरेडी हिंदी में तो मैंने बोल ही दिया था
Ask them to show commentators and QR mics. We'll continue.
नहीं भाई मैं ये ऑलरेडी बोल चुका हूँ एपीजे कलाम सर का
That's okay.
I'll start igniter meet solid versus no solid. नॉइज फ्लेक्सिंग पे बोल दूँ क्या तू बोल मैं बोल नहीं ये मिला रहा नहीं नहीं छोड़
All right. Another fun fact while we wait for this hold to resolve is we always take pride in naming our hardwares, and most of them have been in honor of some exceptional minds. So, Akhil, why don't you tell us about some of our naming conventions?
Yeah, I mean, if you can see in the rocket itself, all our rockets and the launch vehicles are named in the honor of Dr. Vikram Sarabhai, the very like father of Indian space program, we call him. And all our solid rocket motors, their names are dedicated to Dr. APJ Abdul Kalam, our very own missile man. And all our cryogenic engines, we have dedicated the names to Dr. Satish Dhawan, which we are like the center we have also Satish Dhawan Space Center dedicated to him. And then we have our hypergolic engines, Raman. And then we have dedicated that name to Nobel laureate Dr. C.V. Raman, and our mission computer after the renowned mathematician Srinivas Ramanujam.
So yeah, I think we're gonna keep up this idea of naming our hardwares after scientists
until we run out of scientists. Yeah.
Yeah. So I think
Not the hardware.
we need the young budding viewers who've joined us in the launch gallery to become scientists themselves and famed scientists who take India to great heights, so that we may have names.
Yes, right now maybe. Coming to one more interesting fact, I think a lot of people they don't know this. Like, if you look at a launch vehicle, it seems pretty rigid at first. But the interesting fact is when the entire rocket, when in flight, it experiences combined effect of aerodynamic loads, engine thrust, wind gust, and due to different steering maneuvers, the teams or the designers deliberately give some flexure, or like they make rockets slightly less rigid so that it can actually bend along its length throughout the flight. This is intentional, that designing an absolutely rigid rocket would make it significantly heavier and less efficient. And it also creates a complex engineering challenge. As the structure bends, the onboard sensors can detect these motions, so the guidance and control system must distinguish the rocket's actual altitude and structural flexing to avoid unnecessary control corrections. And engineers carefully predict these bending modes and their natural frequencies through the structural dynamics and aeroelastic analysis, ensuring the vehicle remains stable even as it flexes its way through one of the most demanding phases. And this flexure could go up close to 10 centimeters, I think. Yeah, close to 10 centimeters. That's pretty huge.
That's right, Akhil. Something for the kids who might be, looking at this live stream. So rockets don't just fly, they keep falling around Earth. It might be difficult to imagine this, but people often imagine astronauts escaping Earth's gravity. The truth is, gravity never lets go. Even the International Space Station is constantly falling towards the Earth, but it's moving sideways at so high speed that it keeps missing the ground. And that's what we call as orbit.
Yeah, that's wonderfully put.
Orbit is a state of perpetual free fall.
Yeah,
Wow.
that's right. And you spoke about how astronauts on the international space stations are also constantly falling towards Earth. And with us today in the Mission Control Center is our very own astronaut, Shubhanshu Shukla. And he's been following Skyroot's journey from a very close distance. He's part of our family as well. And he's here to cheer us on. So we thank him for his presence.
One more interesting fact for our viewers, that rockets get lighter every second. Unlike an airplane, a rocket becomes lighter every second because it continuously burns and throws away propellant. Because in aircrafts we have air-breathing engines, so the oxidizer itself is the air that the turbofan sucks in. But when you have a rocket, you cannot have. Yeah. So when we are dealing with rockets, there is no air outside air can enter and can be utilized for propulsion. So we have to carry our own bottles of oxidizers and fuel. And once the rocket is ignited and it's on its way through the entire flight, the propellant is expelled, and when the stage gets burned out, it's also thrown away or jettisoned. So that is why rocket keeps accelerating, because there is less and less mass to push.
That's right, Akhil. A rocket may weigh hundreds of tons on the launch pad. Consider our Vikram 1, it weighs around 45,000 kgs on the launch pad, but nearly 90% of that weight is just propellant.
That's really amazing. That structural mass is so less. I mean,
The views on your screen are from the launch gallery at Sriharikota, and we have thousands of students who've joined us from all over the nation, and they're eagerly waiting the launch of India's first privately built orbital launch vehicle, Vikram 1. And of course, like I mentioned earlier, it's a test flight, and we'll be doing a few of these before we move into routine commercial operations. We are in a state of hold for now. For the viewers who've just joined us, we have successfully initiated the automatic launch sequence at T minus 11 minutes, and a lot of the key events that went into this have been executed. We have a hold right now at T minus 5 minutes, and just to recap, we've had the switchover to internal power, wherein the vehicle is now powering itself. All of the null checks on our actuators have been completed. So essentially, the vehicle's steering systems are in great health. And we're at a planned hold. One quick look at the rocket as well, standing on the launch pad. All right, we're getting updates from the mission control teams. The hold that you observe on your screens was due to a hold raised by the navigation team.
Vehicle directed to launch
Where-
control. Please do the needful pre-exercises to reinitiate ALS and confirm your readiness.
And
Copy.
we've gotten confirmation that we will be starting ALS shortly. So please stay tuned. So we had a planned hold, and we've just heard from the mission teams below that we are ready to restart the automatic launch sequence shortly. And just to recap once again, Vikram 1 is on the launch pad. It's ready and eagerly awaiting its first test flight. We've had the initiation of the automatic launch sequence, and through that we've completed the internal power switchover, which means the vehicle is now powering itself using its own batteries. We've also had the null checks been completed, and we're now waiting for the next window to come about for the ALS to restart.
so now that we know that the ALS is on hold and soon we'll be back with a new time and the restart of ALS, let's talk about the entire journey of Vikram 1, the mission sequence. Now we know that first 100 seconds of the flight, the stage 1 will power the rocket to the denser layers of the atmosphere, and exactly at an altitude of 53 kilometers at 103 seconds, the stage 1 burnout will happen and the stage separation will initiate. And after that, the stage 2 will ignite and it will power the rocket through the thinner layers of the atmosphere while keeping the same level of acceleration. That is the point. And later on in the stage 2, during the stage 2 burn duration, later half, you have the payload fairing and it separates, and this is the first time when the payload or the satellite is exposed to the atmosphere or to the space, the higher layers of atmosphere, which is exactly nearly close to space.
Yeah.
Having protected the satellite throughout the ascent, that the fairing's job is done.
Yeah, that's right, Akhil. And you mentioned that the PLF or the payload fairing is the portion that essentially protects the satellite from the difficulties of the environment that the rocket goes through. The question then becomes, how do we separate all our stages, right? So we use something which is very unique and we're very proud of that. In-house to Skyroot, we have the separation teams which have developed a pneumatic ultra-low shock mechanism. And the whole goal of this mechanism is it relays very little shock to the payload itself. So the payloads usually carry very sensitive electronics and instruments. So if you have a shock event come about, it may damage some of the sensitive instruments. So that's why we specifically made it a point to develop this pneumatic ultra-low shock separation mechanism.
Like for the knowledge of our viewers, I would also like to reiterate most typical rockets, they use pyrocords, which use explosive charge to shear out the bolts and separate or jettison the entire stage, which could be catastrophic for some sensitive payloads. That is very costly and could be like, you might lose some data from the satellite and affect its workability.
Control here, go ahead.
Definitely.
Still external hold mode is coming.
Right.
Noted.
Now, even after the payload fairing has separated, the job isn't done yet, right? The climb is still going on. Stage 3 steps in and it generates quite a large amount of thrust to essentially power the vehicle into orbit. It keeps pushing it to near orbital velocities. And then comes something different, like we talked about earlier. We have the orbital adjustment module that kicks in. And this is the stage that I got to work on very closely. Like I mentioned earlier, it was a team of very ingenious, multidisciplinary members. We had teams from systems, propulsion, dynamics,
set the revised
quality, safety, reliability, CFD, design. I mean, you cannot count these fields on the fingers of your hand, and they all had to work in unison
to
build this stage.
All ground stations
and then once it starts working, it will precisely place all of these satellites into its intended orbit. And you might feel like all of this is happening. There's so many things happening, right? But it's just 16 minutes. That's all it takes.
It's so fast, but it seems really long. Like it took us like 1 hour from the entire bus stand to reach Sriharikota. But as Suyash pointed out, so it's such a, we can say the entire rocket engineering, the complexity, looking at the complexity of it, it's like an entire opera house. You have to be like a soprano. You have to be so perfect. Every system, every individual and every component should be in tune to engage all the systems at the right moment so that we can have even a small ignition. And now we have a Vikram 1, which has close to 1,000 subsystems and almost 2/3 of it will be utilized just even at liftoff. That's really fascinating.
So we've gotten confirmation and you might see it on your screen shortly as well. The countdown has restarted. We are resetting to T-minus 20 minutes. And we are at T-minus 19 minutes for the information of all our viewers.
Other ground stations about the new T0. Please confirm.
Control timing in external hold mode.
CNC copied, new PGM files shared.
Roger.
Coming to control timing in external hold mode.
Roger.
We'll take that full bit once again.
Skyroot LCC to all. S2 and S3 HMSEs event number 97 completed.
Roger. Control to LCC, MCC and RSO. Please note timing confirmed, external hold mode.
Skyroot LCC to all station. New T0 is 12:05 30 seconds.
All right, we are hearing from the mission control that the new T0 time or the liftoff time for
T-minus 18
mission
minutes.
Agman is reset to 12:05 p.m. So stay tuned, we'll be with you and we'll give you some more space trivia. We have a lot of those, and we'll also take you through the journey of the rocket as well. You know, many of the times one of the questions that comes is why space? You know, it's so hard. Getting to space is hard enough. Getting to space on the first try is even
All
harder.
stations to note,
So if
mission
it's so
director
hard,
authorized the launch
why do
of
it at all?
Vikram mission Agman.
What does it hold of such huge importance that we want to strive for making to the stars?
I mean, if you think about it, all the activities that happen on Earth, they are connected in some or the other way to space. Space has quietly become a part of our daily life. Every weather forecast, every map that guides us home, every digital payment and long distance call leans on us. It all leans on a satellite somewhere overhead.
And I mean, it's like the human curiosity that takes you really farther. And like humans, we actually like complex things, and we just it's not just enough to stay on one planet. And so that's why the man decided to take a decision to set off to some higher horizons. And it is still, after 80, 90 years, the complexity still remains so high in space travel.
Yeah, and one question that comes about is how do you make all of that happen?
The new launch ISP is 12:05 30 seconds.
Right, we've just gotten call out and confirmation that the new T0 is 12:05 p.m. Just as a reiteration to all our viewers. So we were talking about what it takes to make all of these happen, and of course we would like to thank ISRO for all their support, from opening the doors to the Satish Dhawan Space Center, the historic first launch pad, issuing us guidance and helping us with all the nitty-gritty details. They've worked with us day and night on this. They've treated this vehicle as though it were their own, and they're so committed to making sure that mission Agman reaches its intended orbit that they've essentially become a part and parcel of the Skyroot family.
They treated the vehicle as their own, as you correctly said, Suyash. Like, they have been involved with us throughout the entire campaign,
Vehicle director to
helped
Skyroot
us,
Launch Control.
and along
You
with
can
ISRO, we would
reinitiate
also like to
automated launch
take a
sequence
pause
at
to thank
T-11 minutes.
InSpace, and they have acted as a bridge between the government organization, facilitating all the review meetings, everything, and allowing us access to SHAR, all the policies, all the reforms. So thank you InSpace for all the efforts, and thank you for rooting for Skyroot.
Yeah, one interesting thing, and this is a personal experience as well. We did Mission Prarambh in November 2022, and believe it or not, the headquarters of InSpace were inaugurated in June 2022.
Just 6 months from our first launch.
So you might have to imagine that it's just 6 months, and they've had to imagine and they have to write and draft all the policies that are required. They have to make sure that they know how the mission is going to be, regulated. What do we need to do to essentially handhold the space sector, the private space sector?
It was very seamless, indeed, very seamless. The way they took all of it.
Yeah, very true. It definitely is not an easy job, and they've excelled at it. Same goes with ISRO. We've had, cases where they've been chasing after us.
Yeah. I remember those days.
Yeah, and it's quite, empowering to know that the government is playing such a huge role in helping make this happen. We talk about Atmanirbhar Bharat, we talk about Viksit Bharat 2047, and all of these technologies, what the private sector is trying to build today, is essentially contributing to that goal. If we want to be the world leaders, we need to start now.
Exactly, Suyesh. Like, I was fortunate enough to visit the LPSC test facility when I was with the Raman 1 test campaign. It was a very great experience. I mean, and the coordination with ISRO teams and the way they facilitated the entire test campaign and the data analysis and post-test, the data came like really fast and like they were after us and they were very patient with us. So yeah, that was a really great experience for the young engineer like me.
Yeah, and that sort of reminds me to the stage test that we did just a couple of months ago. I think nearly 9 months ago.
Yeah, around I think October.
Yeah, October I think. And so that was the test of the orbital adjustment module. It was a all-inclusive test. We had the entire stage. We had all the engines, the thrusters. We had the avionics. We had something quite interesting and melodic as well. We played Sare Jahan Se Acha using the Raman Mini thrusters on the stage, which was something very unique, very captivating to the young minds. Many people did not think that you could play music out of the screeching sounds of 50 Newton Raman Mini thrusters.
Again, an opera, I told you, right?
Yeah, definitely.
Just give me a go. When to say? Just give me a go when to say. अभी तो हम pause है ना?
Do one thing. Let it go into earbuds. We'll give the earbuds coming because 3 बार हो गई कि आप छोटे पावर में
T minus 11 minutes.
यहाँ से स्टार्ट करेंगे पर लेकिन तो उसके पहले फिल्म ALS का इंट्रोडक्शन your point ground stations are ready yes and within 9 minutes 9 minutes to रहेगा
Automated launch sequence initiated.
9 minutes तेरे bullet points है तो
Roger.
और फिर then शार अगर SDC हो गया कहाँ पे
शार नहीं
ground station yes perfect. All right, we're at T minus 11 minutes again, T minus 30, 10:30, sorry. And the automatic launch sequence has begun. We are in the pre-checks phase at the moment, where all the teams are essentially checking the health of the vehicle once again, making sure that all systems are operational and go for launch.
Before that, we had one confirmation that all the ground stations supporting today's mission, they have completed their readiness checks. As the vehicle travels downrange, telemetry will seamlessly transition between multiple ground stations, from Shah to Port Blair, then Bogor in Indonesia, and then finally Yatharaga in Australia. This network ensures continuous communication with the launch vehicle, with all mission data relayed back to mission control in real time.
That's right. And just to recap to all our viewers, some of the callouts that have happened till now. We first had the acquisition of day of launch winds, which is we acquire using a Doppler weather radar the winds prevalent. And as Akhil mentioned earlier, it's slightly a cloudy day today for launch, but come rain or sunshine, we are always ready to launch.
Yeah, the rain can't stop us, I think.
Yeah, and the next thing that we managed to do is,
9 minutes.
of course, the guidance teams have completed the static navigation profile as well as the gyro compassing of the LINS package. So this is kind of the sensor which tells the attitude of the vehicle, essentially tells you how you're oriented with respect to Earth. And it's something very important that the vehicle has to do. It needs to know where north is and where the direction of gravity is. Post that, like Vede, he just confirmed, we've had all the ground stations. We have 4 ground stations supporting us today. Shar, which is where we are coming to you live from, and then we have Port Blair, following which we have Bogor in Indonesia, and finally the Yatharga ground station in Australia. So all of these ground stations essentially capture telemetry, which is the data from the vehicle,
minus 8 minutes.
and relay it instantaneously to us.
Yeah, Suyash, you were mentioning about how we also see the wind profiles. The wind profiles are also checked. Just a while back, they were checked. And as I can see on the MCC, this wind profile or this data of the winds is also going to be uploaded into the mission computer in the sequence that is coming up. And also, one of the key milestones which have been completed is the transition from external ground power to the rocket's onboard batteries. The vehicle has relied on ground support systems till now, but from this point forward, every stage must successfully power itself. So engineers, I believe, are watching the battery performances and electric health right now to ensure that the transition is smooth and every system is remaining stable as of now.
And for this
T
ALS
minus
sequence
7
also,
minutes.
we have completed all the null checks for all the stage nozzles, and the FNCs are working as fine as possible. And we are also happy that Dr. Jitendra Singh, Honorable Minister of Space, is joining us live on video call, and he's rooting for Team Skyroot.
We are at T minus 6 minutes and counting. For the viewers who've just joined us recently, on your screens right now is the Skyroot Launch Control Center situated at Shar. We have many engineers looking at the vitals of the vehicle. This includes different teams, starting from avionics,
6 minutes.
guidance, navigation, control, liquid propulsion, solid propulsion, safety, reliability, quality, and of course our IT teams as well. One of the things that has also been completed just now is the uploading of the mission computer init files. And that's a funny name of sorts, but it essentially means initialization files. These are essentially files that contain all the requisite parameters to tell the vehicle what it needs to do in the early ascent of flight. It adjusts for the day of launch wind profiles that we talked about. It also has the gyro compassing
T minus
details
5
within
minutes.
it.
And now we have confirmation that mission computer mode has been successfully changed to flight mode, and we are really jubilant, and everybody is really happy that this stage has been successfully transitioned, and now we'll move towards the next check, that is HMSA disarming.
As we enter the final few minutes of countdown, another key safety milestone is underway. The head mount safe arm mechanism will be activated in a while, and till now it was ensured that the ignition chain has remained safely isolated.
That's right, Vaidehi. For the viewers who are very curious for this, the head mount safe arm mechanism, which we refer to as
T minus 4 minutes.
is a safety device which is mounted at the head of our solid rocket motors. And the whole job of this device is to safely isolate the pyrotechnics from the rest of the solid grain. And the reason why we do that is for safety, to prevent any accidental ignition from let's say lightning strikes. We do have a cloudy day today, and of course we have lightning suppression systems. We have 4 lightning towers on the first launch pad, but there can also be some form of electrical runaway. There can also be static discharge. So to safeguard all these devices from electrical discharges, we have a mechanical separation between the pyro devices and the solid rocket motor.
Right, so yes. So till now, the ignition system,
T
it
minus
was
3
in
minutes.
a protective, non-firing state, but now it's going to move on to a state wherein once the mission computer gives the ignite command, it can initiate a pyrotechnic chain of events.
That's right. And we're at T minus 3 minutes, and we have confirmation that the stage 1 head mount safe arm mechanism, or the stage 1 HMSA, has been successfully armed.
This basically means that our motor is now ready to ignite.
That's really great to hear. Along with this HMSA safety mechanism, we have one more layer of safety which we call the FTS or the CDS, Command District System, or the Flight Termination System. This is utilized when if the vehicle during its flight mode tries to or like deviates from its intended flight trajectory, then the range safety officer can take a call to distract the vehicle to safeguard the resources around it.
T minus 2 minutes.
That's right. As is with the case with any launch vehicle, we always prioritize safety, and with that in mind, we have all of these systems set up on the vehicle. We are now entering to condition the liquid stages on Vikram 1. So the orbital adjustment module is now conditioning itself and preparing for liftoff. So we are nearly at T minus 1 minute.
All stations
And
stand by for the
we
timer.
will leave you
T
with
minus
the
1 minute.
views of Vikram 1 and join you shortly at liftoff.
Minus 55 seconds. Minus 50 seconds. Minus 45 seconds. Minus 40 seconds. Minus 35 seconds. Minus 30 seconds.
Real-time programs activated.
Minus 25 seconds. Minus 20 seconds.
Minus 20 seconds is the call out now.
Minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
And we have liftoff of Vikram 1, India's first private orbital launch vehicle. And we have great views coming from the tracking cameras. And isn't this quite something?
विक्रम 1 ने अपनी उड़ान भरी है। प्रथम चरण का प्रज्वलन प्रारंभ हो चुका है। विक्रम 1 ने प्रक्षेपण पथ को लांघकर आकाश को भेदने का निर्णय ले लिया है एक ब्रह्मास्त्र की तरह।
That's very true, Suyash and Akhil. I am awestruck at the sheer power that stage 1 is producing. With this, we have two of our major prime mission objectives completed, which was successful ignition and safe tower clearance.
That's right. And we're coming up on max Q now, which is the period of maximum aerodynamic pressure, where the vehicle faces its largest aerodynamic loads as it flies through this zone at Mach 1.5 at an altitude of nearly 9 kilometers.
विक्रम 1 ने सफलतापूर्वक मैक्स क्षेत्र पार कर लिया है और दल काफी उत्साहित है इस समय और विक्रम 1 प्रथम चरण के आगे बढ़ रहा है और हमें श्रीहरिकोटा व पोर्ट ब्लेयर पृथ्वी स्टेशन से मजबूत दूर संकेत मिल रहे हैं जो बहुत ही अच्छी खबर है।
That's right. We are at a downrange distance of 22 kilometers. with an altitude of 34 kilometers. And on your screens right now are excellent onboard camera views from the vehicle.
And we can also see quite nominal chamber pressure values on the MCC screen.
The vehicle is currently at an altitude of 50 kilometers.
और यहाँ पे प्रथम चरण का प्रतिकरण हो चुका है और द्वितीय चरण का प्रज्वलन भी प्रारंभ हो चुका है.
This is quite a major achievement for the nation, with the vehicle successfully separating stage 1 and the ignition of stage 2 as well.
द्वितीय चरण अपना सफलतापूर्वक कार्य पूरा कर रहा है और प्रथम चरण का दहन अथवा प्रतिकरण समाप्त हो चुका है.
The vehicle is at an altitude of 89 kilometers, traveling at 2.6 kilometers per second. Of course, our target velocity for today is 7.6.
S2 performance normal.
We've just heard call out that the S2 performance or the stage 2 performance is nominal.
ये एक ऐतिहासिक क्षण है पूरे भारत और निजी अंतरिक्ष यात्रा का.
This vehicle has crossed 100 kilometers of altitude, which is the notion of edge of space, and we have reached space, guys.
Congratulations, Vikram 1 is in space.
हमारा यान अंतरिक्ष तक पहुंच चुका है.
And we've had callouts of separation of the payload fairing. We have successful payload fairing separation.
It's nearly at an altitude of 120 kilometers, and the protective fairing is no longer required and has been cleanly separated from the launch vehicle.
और यहाँ पे द्वितीय चरण का भी प्रतिकरण संपन्न हो चुका है और तृतीय चरण का प्रज्वलन भी प्रारंभ हो चुका है.
That's right, Akhil. We've had successful ignition of stage 3. The vehicle is currently at 157 kilometers above the Earth's surface. It is 355 kilometers downrange, traveling at nearly 4 kilometers per second. Now the telemetry will switch over from Shar to Port Blair and further to Bogor.
अब यान अपनी अंतरिक्ष यात्रा पर निकल चुका है. तृतीय चरण का प्रज्वलन चालू है और उस
+4 minutes
की प्रतिक्रिया नियमित रूप से चल रही है.
And as you can see on your screens, we have near exact following of the intended trajectory. The two lines on your screen essentially indicate the current performance of the vehicle, and it closely matches with prediction. This is on your screen on board from stage 3. What you see is the rocket plume and the nozzle, and Earth, our home.
What a beautiful view. क्या सुंदर दृश्य है हमारी पृथ्वी का.
S3 performance normal.
और तृतीय चरण का परफॉर्मेंस अब नॉर्मल है, या कि सामान्य रूप से तृतीय चरण का संचालन प्रारंभ हो चुका है और चल रहा है.
That's right. We've had call out that the stage 3 performance is nominal.
+5 minutes.
So stage 3 has a propellant loading of 2.5 tons, and we've had burnout of the stage 3 motor as planned at T plus 5 minutes. Yes, we've gotten confirmation that S3 has burnt out, and now we're entering a planned coast period, something that lasts for 140 seconds, in which it's called as combined
coasting is normal.
Right, so we've got call out that the combined coast is nominal. This will last for roughly 140 seconds, where stage 3 is not producing thrust, but it's connected to the vehicle and it's going to coast as a single body. All of this is done to manage the altitude of the vehicle and also control where the stage will re-enter the Earth's atmosphere before splashing in international waters in a safe and planned manner. And jubilant views from the launch control center, where the teams are extremely elated and excited.
और मिशन नियंत्रण केंद्र और लॉन्च नियंत्रण केंद्र से आपको दृश्य दिखाई दे रहे हैं. सभी यान परीक्षण दल अत्यंत ही प्रसन्न हैं और यहाँ पर जो प्रसंग है वो एक उत्सव का प्रसंग बन चुका है, एक ऐतिहासिक क्षण भारत के निजी अंतरिक्ष उड़ान का। विक्रम 1 यान अब अंतरिक्ष में स्थापित हो चुका है। तृतीय चरण अब अपने कोस्ट फेज पे है और ये कोस्ट फेज अभी आप कैमरा व्यूज देख सकते हैं अपने प्रक्षेपण पर्दों या मोबाइल स्क्रीन्स पर, जहां पे आपको धरती का एक सुंदर दृश्य दिखाई दे रहा है।
As we can see on our screens right now, it's really amazing to see that Vikram 1 as of now is going along its intended trajectory exactly as expected. Our plots are really overlapping. The predicted velocities and the current flight velocities are exactly matching. And aren't you guys speechless right now?
I mean, मेरे पास शब्द ही नहीं है, मतलब ये मैं निशब्द हो चुका हूँ।
That's right. We are approaching another point wherein S3 will separate.
S3 is separated.
और तृतीय चरण का प्रतिकरण भी हो चुका है।
And you see wonderful views of S3 separating. And now we have combined coasting has ended, and stage 4 will now coast on its own for the next 130 seconds. So stage 4 will now fly on its own, essentially, and
the control thrusters on the OM will be continuously turning on and off to maintain the attitude of the stage, making sure that it is pointing the right way. This also ensures that the antennas can maintain connection with the ground station and the satellite can be pointing in the right direction.
That's right. So one unique thing that has been done during separation is we've essentially fired all 4 of our Raman Mini thrusters to sort of push stage 4 away from stage 3. And that just sort of guarantees that there is some minimum separation between the two.
अब आने वाला जो चरण है वो द्रव्य प्रणोदन पर आधारित होगा, जिसको हम कक्षा स्थापन या समायोजन खंड ऑर्बिट एडजस्टमेंट मॉड्यूल के नाम से भी जानते हैं, जिसमें द्रव्य प्रणोदन की अवस्थाओं से संचालन होगा जो मोनोमिथाइल हाइड्रोजीन और डाइनाइट्रोजन टाइट्राऑक्साइड पे आधारित है। उसके साथ यान के घूर्णी नियंत्रण के लिए, जिसे कंट्रोल थ्रस्टर्स कहते हैं हम लोग, उन रामन मिनी 50 न्यूटन, वो भी मोनोमिथाइल हाइड्रोजीन और डाइनाइट्रोजन टेट्रा ऑक्साइड पर ही आधारित है। उसके अंतर्गत हमारे पास छोटे कोल्ड गैस थ्रस्टर्स जो कि नाइट्रोजन गैस पर आधारित हैं, वो भी कक्षा समायोजन खंड पे स्थित हैं।
S4 ignited.
And we've heard call out that S4 or stage 4 has ignited successfully.
और चतुर्थ और अंतिम चरण का भी प्रज्वलन हो चुका है।
The liquid engine has come alive over 400 kilometers above the Earth, beginning a burn that will last for more than 6 minutes. During this phase, the vehicle will steadily accelerate from about 6.68 kilometers per second to nearly 7.64 kilometers per second, delivering the precise velocity needed to achieve its planned 450 by 450 kilometers circular low Earth orbit at a 60-degree inclination.
और यहाँ पे आप देख सकते हैं कि प्रक्षेपण नियंत्रण केंद्र में उत्साह का एक प्रसंग आ चुका है और आपके ऑन बोर्ड प्रक्षेपक पर्दों पर हम देख सकते हैं कि पेलोड्स या जो उपग्रह हैं उनका एक चित्र, यहाँ पे सारे उपग्रह अपने स्थान पर स्थित हैं।
That's right, Akhil. We've also had seamless transition from the
S4 performance normal
to the Bogor station, and now we are receiving strong telemetry from the Bogor as well as the Yatharga stations in Indonesia and Australia respectively. The current altitude of the vehicle is 426 kilometers. Our target is near 450. We're traveling at 6.5 kilometers per second. And like we said earlier, OAM is essentially going to fire its Raman 2 engine for a cumulative burn time of nearly 6+ minutes. So this is the longest burning. It's the smallest in thrust, but it burns for the longest period of time. And it's all given to us by Raman 2, our main engine for this mission.
So yes, it must be a really amazing feeling, right? I mean, you and your team worked on this engine to get it going, and it is finally taking us to space.
Yeah, it's a feeling that's really hard to describe. Me and my team, we worked on this engine to get it going, and it's finally taking us to space. This engine wasn't an easy design. Raman 2 generates 1500 newtons of thrust, and it employs 3 different types of cooling. As if one wasn't enough, we had to put in 3. So we have regenerative cooling, then we have radiative cooling, and we have film cooling. And all 3 of these need to work seamlessly in sync to deliver this phenomenal outcome. So I'm kind of glued to the screens right now. You might just see me peeking over to try to see what the chamber pressure, what the thrust, and what the temperatures are like. But I think I might have to hold for a bit and look at that data in a little while. So while I was talking about Raman 2 and how difficult it was to essentially design an engine this small, like I said, it's a relatively small engine, and the cooling design on this was exceptionally difficult to manage because the engine has to generate a lot of heat during combustion, and the temperatures can reach up to 2700 degrees. That's pretty hot for any metal or any material to sustain. In fact, many metals would just vaporize into thin air at those temperatures. So to make all of this work, we employ something known as regenerative cooling.
S4 performance normal.
Yeah, and we've gotten call out that the S4 performance is nominal. And so I was mentioning about the regenerative cooling, and the best way to understand this type of cooling is to imagine
14 minutes.
multiple tubes joined side by side and then arranged into a circular fashion to form the thrust chamber. And these tubes, they need to be very, very thin to exchange heat effectively, which means that manufacturing is usually a challenge. And even after the temperatures would still be too high for normal metals to handle. And for this exact purpose, we employ something known as film cooling. And even though it sounds like a fancy name, it just involves injecting fine jets of fuel along the walls of the chamber to effectively add a barrier of colder gas between the combustion chamber and the metal walls. And essentially, one question I get asked very often is, if it's like that, then why is it called regenerative cooling, right? The whole thought process is the tiny tubes that we just talked about. Those tubes
performance normal
plus 15 minutes.
और यहाँ पर हमको मिशन नियंत्रण केंद्र संकेत मिल रहे हैं कि चतुर्थ चरण का भी परफॉर्मेंस सामान्य है और अभी यान 450 किलोमीटर की ऊंचाई तक पहुंच चुका है जो कि उसका निर्धारित कक्षा है और कोस्ट फेज प्रारंभ है।
जी हाँ, and it's traveling at 7.3 kilometers per second at an altitude of 453 kilometers right now. So coming back to the regenerative cooling point of things, the tiny tubes around the thrust chamber of the engine essentially have fuel pumped through it.
S4 thrust cutoff.
And we've got confirmation that we have cutoff of the Raman 2 engine, which means
Solaris
that
satellite separate.
and we have separation of the Solaris satellite and the Scope satellite.
Vikram
Both satellites have been deployed
successfully.
successfully, and we have reached space on our first
जी
attempt
हाँ,
successfully.
इतिहास में पहली बार एक यान ने अपने प्रथम परीक्षण उड़ान में ही उपग्रहों को उनकी निर्धारित कक्षा में स्थापित कर दिया है.
And now comes something very, very interesting. You can see on your screen from on board the cosmic bloom and the micro art. And we have sun rising behind it. It is the dawn of a new space era.
ये एक नए अंतरिक्ष युग का प्रारंभ है. सूर्य के किरण ने ये प्रकाशित कर दिया है.
Skyroot has actually completely redefined orbital flights, I guess, forever.
Yes, अवश्य. ये कथन बिल्कुल
Plus
सही है.
17 minutes.
So right now we are awaiting
Hello
the
everybody.
Cosmoserve
Today we have
satellite
created history.
to
Vikram
perform.
1 Agaman mission is a grand success.
And we've heard call out from the mission director that the Agaman mission is a grand success.
सफलतापूर्वक प्रथम मिशन आगमन ने इतिहास के पन्नों में अपना नाम अंकित कर दिया है.
Hello space, we have arrived. Thank you for joining us today.
Thank you for being with us on this historic journey today. With Raman 2 and Vikram 1 now safely in orbit, we are not just reaching space, we are opening space for all.
आज की इस ऐतिहासिक उड़ान में हमारे साथ जुड़ने के लिए आपका हार्दिक धन्यवाद. विक्रम 1 ने सफलतापूर्वक सारे उपग्रहों को कक्षा में पहुंचा दिया है और भारत के अंतरिक्ष सफर में एक नया उज्जवल अध्याय खोल दिया है. धन्यवाद. जय हिंद, जय भारत.
Good afternoon. Good afternoon, everyone. We'll let them celebrate. Good afternoon. I am privileged to formally announce that the first ever Indian private sector launch has been successfully completed. Not only did Vikram 1 meet its mission objective, which was simply to clear the tower. It went all the way up to 453-kilometer orbit, successfully completed all the tasks, and something that is way beyond expectation for the very first orbital launch ever taken by an Indian private company. There is not much more that I want to say on this occasion. I would like to invite Pawan and Bharat to talk about their journey and how they feel today, this momentous milestone that Indian private sector space initiatives have had. And I would like to thank everyone involved in this, of course the Skyroot team. The Skyroot team has worked day and night to make this day happen, ably supported by the team from SAR, from extended ISRO, and from InSpace. So thank you everyone for giving India this proud moment. Thank you.
You can start pouring.
No, let's wait.
हाँ जी, आ रही है। हाँ, आ रही है।
जी सर, मैं पीएम साहब को लाइन दे रहा हूँ, आप लाइन पर हैं?
हेलो
हेलो सर।
हेलो, नमस्ते। कौन बोल रहे हैं?
हेलो वी आर पवन एंड भरत फ्रॉम स्काईरूट।
कौन बोल रहे हैं?
Sir, we are very privileged to hear you. First, your voice after the success.
पवन, भारत और पूरी टीम, सबसे पहले तो आपको बहुत बहुत बधाई। आपने दो काम किए हैं। एक तो आसमान में नए पौधे गाड़ दिए हैं और दूसरा जमीन में भी उस रूट्स को आपने मजबूती दी है जो देश के नौजवानों को आगे आने की प्रेरणा देगी। और मुझे ये सफलता के लिए तो आनंद होना ही होना था, लेकिन आप लोगों ने जिस कमिटमेंट के साथ मेहनत की, और मैं जब आपके इंफिनिटी कैंपस के उद्घाटन के लिए आपके साथ जुड़ा था, मेरे तो मन करता था मैं पहुंचूं, लेकिन पहुंच नहीं पाया, लेकिन आपके साथ वीडियो से जुड़ा था। और आज भी मैं इस पूरे लॉन्चिंग कार्यक्रम को देख रहा था। कब से मेरा ध्यान जो गया, आपकी पूरी टीम 25-30 साल की दिखती है। ये मुझे और खुशी दे रही थी। शुरू में आपके चेहरे पर चिंता भी नजर आती थी, लेकिन फिर मैं देख रहा था कि खुशियों से माहौल भर गया। मैं आपको, आपकी पूरी टीम को इस महत्वपूर्ण निर्णय के लिए और महत्वपूर्ण सफलता के लिए मैं बहुत बहुत बधाई देता हूं। जब हम स्पेस को प्राइवेटाइज करना चाहते थे, तब मेरे सामने कई सारी आशंकाएं रखी गई थी। ये तो हो नहीं सकता, कैसे करोगे, वैसे करोगे, लेकिन मैं इसको आगे बढ़ता ही गया। अब आपके कारण मेरे उस निर्णय को ताकत मिल गई है। अब मेरी टीम भी स्वीकार करेगी कि हाँ, देश के नौजवानों पर भरोसा करना चाहिए, उनको काम देना चाहिए, और वो करके दिखाते हैं। आपने काम करके दिखाया है। मैं आपकी और आपकी टीम को फिर से एक बार बहुत बहुत बधाई देता हूं।
Hello sir. Thanks a lot for your wishes. And our team, entire team of Skyroot, more than 1,000 people are here in Sriharikota and listening to you. Our hearts are swelling with pride, and this means a lot to us.
देखिए, ये मिशन आगमन है। अब आगमन को तो और आगे बढ़ते ही जाना है।
Sure sir. और सर आपका कार्ड जो आप भेजे थे, that has successfully reached space and you have written Vande Mataram. So Vande Mataram is in orbit.
देखिए, मेरे लिए बहुत खुशी की बात है, जब आपने सुझाव भेजा तो मेरे मन में कई विचार आए थे, लेकिन आखिर जब मैंने सोचा मैं सिर्फ वंदे मातरम लिखूंगा। उसके दो कारण थे। इस बार हमारा देश वंदे मातरम के 150 वर्ष मना रहा है, तो मैं चाहता था कि इसको एक नए तरीके से मनाएं, और वंदे मातरम ही था जिसने देश के नौजवानों को हमेशा देश के लिए जीने मरने की प्रेरणा दी थी। और आज वंदे मातरम हमें देश के लिए जीने की ताकत देता है और आप लोगों ने जी करके दिखाया है। आपका जो कुछ भी मिशन है, मैं इसको एक प्रकार से वंदे मातरम मिशन ही देखता हूं कि भारत मां की गरिमा को नई ऊंचाइयों पर पहुंचाना, नई पीढ़ी को टेक्नोलॉजी को लाभ देना और नई पीढ़ी को टेक्नोलॉजी में आने के लिए प्रेरित करना, हर प्रकार से। और उसमें से मेरे मन में विचार आया कि लंबा कुछ ना लिखूं, सिर्फ वंदे मातरम मेरे भाव व्यक्त करूं। और मुझे खुशी है कि कल आपने उस बात को मीडिया से भी शेयर किया और आज इस सफलता के साथ वंदे मातरम का भाव भी नई ऊंचाइयों को पार कर रहा है।
थैंक यू सर।
मैं आपकी पूरी टीम को बहुत बहुत बधाई देता हूं और जल्द से जल्द आपको मिलने के लिए निमंत्रण भी देता हूं।
Thank you, sir. Thanks a lot. Thank you, sir. We are privileged to hear you. I'm privileged to have your blessings. Entire team of Skyroot, entire India is really proud of your initiative to start the space program, open it up to private sector, and now we see historically, first time probably a private company have built and successfully reached an orbit in the first attempt. Thanks a lot. It's happening from India, and this is a 100% designed in India rocket, 100% manufactured in India, and I think thanks to entire team Skyroot, whose average age is just 28 years.
देखिए, समय था जब मैं आत्मनिर्भर भारत की बात करता था तो ना समझी में कुछ लोग उसकी मजाक उड़ाते थे, लेकिन आज आपने सिद्ध कर दिया कि हम इस क्षेत्र में भी आत्मनिर्भर बनने में समर्थ हैं और आपने उस समर्था को दिखाया है। और मैं पक्का मानता हूं कि अब सबूत हमारे सामने है, साक्ष्य हमारे सामने है और ये आपकी टीम ने करके दिखाया है।
Thank you, sir. Thank you.
आज तो आपकी टीम खुशियां मनाने में लग रहेगी।
जरूर सर। एंड इनफैक्ट हम जब 2018 में स्काईरूट स्टार्ट किया था, उस टाइम पॉलिसी नहीं थे, देयर वाज नो फंडिंग एनवायरनमेंट और प्राइवेट सेक्टर में टैलेंट भी नहीं था, और हम फिर से हमारा जॉब्स छोड़ के स्काईरूट चालू किया था। And now we are very proud that the government is enabled us and opened up the sector to private players, and now we stand as India's first private company which have launched a rocket to orbit and also created a global milestone, all from India, with a fully Indian team, 100% built in India. Thanks a lot for enabling this journey and also setting a big vision for 50 launches in 2030. Definitely, I don't see it as a challenge, sir. Thanks a lot for your encouragement, and looking forward to meet you, sir, in person.
आप आगे बढ़िए, मैं पूरी तरह आपके साथ हूँ और आपको तो आगे बढ़िए नहीं कहना चाहिए, मुझे कहना चाहिए और ऊपर उड़िए।
Thank you, sir. जरूर सर, thank you, thanks a lot, sir.
चलिए, बहुत अभी आपको कुछ न कुछ काम होगा, लेकिन सबसे पहले मेरा आपकी टीम को सचमुच में मुझे देखकर तो खुशी हो रही थी कि इतने मेरे देश के नौजवान क्या कमाल कर रहे हैं। यही मेरे लिए खुशी की बात थी। बहुत बहुत बधाई फिर से एक बार और बहुत बहुत शुभकामनाएं। और आपने जो टारगेट तय किया है वो समय से पहले टारगेट पूरा होगा, मुझे पक्का विश्वास है।
थैंक यू सर, थैंक्स अ लॉट। हम जरूर कोशिश करेंगे।
ऑल द बेस्ट।
थैंक यू। come here. Absolutely no words. Absolutely no words. Go! Go! It's so heartening to hear the Honorable Prime Minister talk so highly about Skyroot, so highly about India's youth. I think this is a historic moment, not just for Skyroot, for India, and also entire global space sector. In the first attempt reaching orbit, I never thought it was possible, and Skyroot team made it possible. Big shout out to this phenomenal team which made it happen. And in fact, this launch was nothing short of a suspense movie. We all experienced the highs, and never have we seen such suspense. And I think it's all worth it at the end. And I think really happy today, and that we have achieved something very rare, very unique. It shows the potential of India's talent. And today, in fact, we stand here at one of the best spaceports in the world, and we are very proud to launch Vikram 1 from the most versatile launch pads in the world, and really thank ISRO for enabling this. And more importantly, I would like to appreciate and also thank entire InSpace team, which has efficiently authorized this launch. And in fact, I've seen companies waiting for launch authorization for so much time, and India has proved it that government is the most efficient. And in fact, they enabled this launch in record time. There was zero delay in authorizing India's first private orbital launch. And like I was telling the Honorable Prime Minister with pride, this is a 100% designed in India rocket, 100% made in India rocket, built by 100% Indian people, for India, for the world. So in fact, I've written a speech, but I'm just out of words. And I'm so happy today, and really, this journey is only possible because first, Team Skyroot, of course, the government, the Honorable Prime Minister, for his vision to open up the sector to private players. And then now today, India is proud to be the fastest growing space tech ecosystem in the world. And now we achieve one of the biggest milestones ever in India's space sector. First private orbital rocket reaching orbit in the very first attempt. It still feels like a dream, and you all made this dream happen. I have no more words, and really appreciate everybody making this happen. In fact, we can see, I think all the hearts were racing up. It was not Skyroot, it was not InSpace, it was not ISRO, it was not the people watching, the public watching in the gallery, people watching online. Everybody's heart was beating for India, everybody's heart was beating for Mission Agaman. And we made it happen. It's one nation, one mission for the world. Thank you.
So I request all the Skyroot folks here, just come up on the stage. Don't leave any inch remaining on the stage. Please occupy the stage now. So as mentioned, there's simply we wanted to prepare something, but there's just simply no words. I just wanted to send the deep sense of gratitude to InSpace for being the enabling pillar